This is the demonstration video for the Robot Modeling Challenge from WP Davidson High School. We are going to showcase the process of how we imported our robot's CAD files and simulated its motion on the field using Simscape Multibody. Our team has spent days and nights designing our robot, Gray. Our designer used the SolidWorks software to create Gray's CAD model and the field assembly. In order to import our CAD files into Simscape, we exported our SolidWorks assemblies as STL files, which is a format that Simscape recognizes. One thing to notice here when we are saving our STL file is that we want to make sure we save all components in a single file so that we won't end up getting too many files. And we also need to export our field assembly as a STL file in order to get it into Simscape. Now, after we exported our CAD model as a STL file, we can simply open Simscape by typing in smnew in MATLAB. We saved the STL files for both the robot and the field into a Simscape block called FileSolid. FileSolid allows us to import our CAD model into Simscape and customize the physical parameters such as mass, inertia, and even color. And here, as you can see, our CAD model is successfully imported into Simscape. One problem we ran into when importing the CAD models into Simscape is that the solids were oriented incorrectly, and our robot was not positioned correctly on the field. We also corrected the field and robot orientation by redefining the primary axis and the front axis options. After we imported our robot and field CAD models into Simscape, we positioned the robot to the starting position for the autonomous brain biopsy procedure. Next, we explored physical motion and autonomous algorithms in Simscape. To implement autonomy in the simulation, we use a Simulink Stateflow Chart, which is similar to how we implemented our real-world line follower at the best robotics competition. Stateflow is like a flowchart that progresses based on the condition we define. In the case of our Simscape simulation, our Stateflow Chart controls the robot's right and left motors based on timing. Been waiting for so long. Now, let's run the simulation. As you can see, the robot is doing the brain biopsy procedure autonomously. We use the Stateflow Chart as our control algorithm. Our robot simulation demonstrates mobility across the environment. We use revolute joints in Simscape to model the wheel axles. We also use the spatial contact force block to model the frictional forces between the four drive wheels and the floor, allowing the robot to move around. We also implemented interactive drive control in our Simscape model using these knobs. I will demonstrate some turning by adjusting these controls, which can be used to simulate other robot tasks, such as heart ablation. Simscape has allowed us to simulate the robot with real-world gravity and physics, so we could verify our robot performance and functionality before physically assembling it. This gave us a great advantage, allowing us to use our time more efficiently and create more precise designs.